This is problem 49, chapter 17 of Giancoli's 6th edition. So we have a homemade capacitor, which is assembled by placing two 9-inch pies. Okay, so that's a inch pie pen. So that's the thing is I got two pens, put these two plates next to each other, and call this a capacitor. Okay, so these are metallic plates, and I call this a capacitor. Now, when they say 9-inch pie, what they mean here is the diameter. The diameter of each one of these plates is 9 inches. Okay, so from this information, I can find the area of these plates. What is going to be the area? The area is pi r squared. Okay, so divide this diameter by 2 and careful put it in meters and we'll find the area. Okay, so all this information here is to give us the area. They also tell us that these two pies, these two plates, are separated by a distance. In my case here, the distance is 5 centimeters. Again, put this in meters. All right. And I connect these two plates with a battery. The potential difference of this battery is 9 volts. Okay, so this potential difference of the battery will also be the potential difference of my capacitor. Very well, so this is all they give us, and now comes a sequence of questions. So the first question is, let's estimate the capacitance. Well, we know that the capacitance depends on the medium in between, the constant, depends on the area, we found the area, and depends on the distance between the plates. So we have everything to get the capacitance. B. Question B is the charge on each plate. We know that the charge is Q is CV. We have C, we also know the battery, and we can find the charge. Careful just with all these units. No? Part C. Part C is trying to trick you because look how they ask. They want to know what is the electric field halfway between the plates. Well, this is a question that almost doesn't make sense. The electric field halfway is the electric field at any point between the plates. Okay? Anywhere between the plates has the same electric field. Okay? So this, let's say this is the positive side, this is the negative side. The electric field established between the plates is constant. What changes is the potential. The potential decreases, yes, but the electric field, no. The value of the electric field is the same throughout between these two plates. You may say, oh, but wait a second. As we move away from the positive charge, isn't this electric field decreasing? Well, it is the magnitude caused by the positive is decreasing, but it's also increasing because the negative one. Okay, so anywhere between these plates, the electric field is the same. And another way to remember that is, remember what is the equation for the electric field? The electric field is the potential difference divided by D. And so all that we care about is the potential difference between the two plates. Okay, so electric field between two plates is constant. What changes, what decreases is the potential. Now we have one side is high potential, the other side is low potential. Okay, what is the next question here? The part question D, the work. What is the work that the battery does to charge the plates? It's not an easy thing. The battery has to inject energy, it has to do work to charge this plate. And what is this work? Remember, we've discussed this in class, is QV divided by 2. The more charge I bring, the more difficult it gets. So I do an average, I get this QV divided by 2. All right, now comes a question. If now I bring a dielectric and I put this dielectric here, I put my dielectric here between these two plates, what will happen to each one of the things that I computed? So I'm going to start from the capacitance. What will happen to the capacitance if I bring a dielectric here? Well, I know that the capacitance will increase. So capacitance increases when I put a dielectric. What happens then to the charge? The battery, we should even have started from this. No, what is constant in this story? What does not change in this story? Well, the only thing that they are telling us here is that we are bringing a dielectric. Nothing has been changed about the battery. The battery is still there. So the battery, the potential difference is fixed. Okay. If I increase the capacitance because I brought a dielectric, because now this capacitor can receive more charge, then yes, that's exactly what is going to happen to this charge. The charge will also increase. What happens to the electric field? Well, the electric field only depends on the potential difference, only depends on the battery that I put there. So the electric field does not change. Does not change. And what happens to the work? Well, I will be putting more charge there, so the work will have to increase also. Now the potential difference is fixed, but since I will have now more charge, the work also will have to increase. And that's it.